Okay, so we're starting 6.6, which is solving rational equations, or actually not. We did a little bit of 6.6 last time, right? Yeah. So, yes, we will do more. So we'll just review. When is your test? Is it not tomorrow? Wednesday. Oh, then we have time to do 6.7, don't we? Or you want to review for final? Or chapter 6 and final? All right, so why don't we do that? Okay, so 6.6 is our last section. Okay, all right. Now let's start. Share desktop. Okay, then I think we should do that. All right, so math 115, 6.6. Oh, this is what we did last time, right? Okay. Yes, we did 2 problems. Yes. So let's do more. I think we should do 6.7. So there is proportion, there is work, there is motion. I think we should do 6.7. Because if you miss it, I think it's important. Work, motion, and proportion. So let me look at it and then let's see. Okay. So now let's do number 3. So we did this too last time on 6.6. 6.6. Let's see. All right. 9982, and then 1 2 4 5 1 2 3 4. Okay. So hold on. Selection, bit inverse, 915, chapter 6. Okay, so what about this? Okay. Now, number 3. Remember, you have to check the solution if it makes the denominator 0 or not, right? Okay, so number 3. What about if we have, let's see here. This is proportion. Okay, number x over x plus 5 minus 5 over x minus 5 is equal to 14 over x squared minus 25. So what would you do first here for x squared minus 25? Factor it. How do we factor x squared minus 25? X plus 5, x minus 5, right. So what is my LCD? X plus 5, x minus 5, right? So what do we do to the LCD? We will clear the fraction. X plus 5 times x minus 5, x plus 5 times x minus 5, x plus 5 times x minus 5, right? Okay. So now the x plus 5 cancel. And here, which one cancel? The x minus 5? And here, both cancel. All right. So what are you left with? X times x minus 5. Good. Minus 5 times x plus 5. So be careful, this is negative 5x minus 25 is equal to 14. Yeah. Good. Now, what is this? X squared minus 5x minus 5x minus 25 is equal to 14. Yay. Cool? All right. So what is this? X squared minus 10x minus 25 is equal to 14. Yes. Then what? What did I do? Then what next? Bring the 14 to the other side. Yes, so subtract 14 both sides. So x squared minus 10x minus 39 is equal to 0. Is it factorable? What is this? Yes. So what are the numbers? Is it factorable? 39 is what? 3 times 13. So that would look, right? Plus 3 minus 13 is 0? Yeah? Okay. So what is x? Negative 3 or x? Positive 13. Which one works? Negative 3, does negative 3 work? So does it make the denominator equal 0? No, right? So this is a solution. Yes. What about 13? Does it work? Does it make the denominator 0? 13 plus 5, is it 0? No. 13 minus 5, is it 0? So this is a solution. So we just want to make sure the bottom is not 0. So you have two solutions, and they are negative 3 and positive 13. Yes, this is quadratic. If it is quadratic, then you have to change it to standard form, right? Because otherwise we cannot solve, right? Even when we use the quadratic formula, remember? Yes. This is 6.6. Yeah. So your next test on Wednesday, you will have your quadratic formula. So quadratic formula and these. Yeah. Okay. Now, next one. Why don't you try this? Why don't you try this one? Number 4. 5 over t minus 2 plus 3t over t minus 2 is equal to 4 over t squared minus 4t plus 4. Okay, and then one more. Okay, maybe this one is fine. So number 5. So give space, okay? Don't give some space because this is pretty long. 12 minus 6x over x squared minus 4 is equal to 3x over x plus 2 minus 3 minus 2x over 2 minus x. All right. So this one, you have to write this. You have to recognize that these ones are what? The opposite of x minus 2, right? So this is the opposite. Remember, this is the opposite of x minus 2. Yeah? Okay. So rewrite it in terms of x minus 2. All right. Okay, guys, try it. Maybe I'll go to the ladies' room. Would you please try 4 and 5? Okay, go to ladies' room. Please try.
All cancel one. I think because it only has one key. Like you just put one in. Would you get 3 keys for it? So that's 3 keys for minus 2. Minus 4. So that's 3 keys for minus 14.
How about the second one?
What's up?
Okay. 2 minutes, 2 minutes. Okay. You guys can call here or else?
Alright.
This is 7B.
What? Hey.
Oh, the 74 is good? 80. That's too high. Okay, guys, work on it, work on it, work on it. You done, Brian? Oh, the first one's done. What's the answer? Yeah, it's -2, right? -2 or -3? Let me see. Is it -2 or -3? -2, yes. Yeah. Okay, what about the other one? What's the answer? -2 and 7/3. But what about the other one, number 2? Not yet? Oh, okay. Okay. So I'm going to copy the second one and then put it on a different page. Oh, it doesn't work. Oh, yeah. Okay, good. Okay, so let's do number 4. Okay, so what do we do here? Factor 3p squared minus 4p plus 4. How do we factor this? P minus 2 squared, right? Okay. P minus 2 squared. So what is the LCD? P minus 2 squared. Yes. Good. So let's multiply each term by the LCD. P minus 2 squared. P minus 2 squared. P minus 2 squared. Okay, so let's see which one cancels here. Oh, just 1p minus 2, and here we have also 1p minus 2. What about these? Both. Yes. Did everybody get the same thing? So what next? 5 times p minus 2 plus 3p times p minus 2 is equal to 4. Yes. Good. And what is left next? 5p minus 10 plus 3p squared minus 6p is equal to 4. Yay, nay? Then what? This is quadratic. So quadratic means you need 1 0, right? So 3p squared minus p, is it? And then we subtract 4 both sides. Minus 14 is equal to 0. Okay, good. Now, how do we factor this? AC method. Do you remember AC method? Okay. So then what do we factor this? 3p divided by 3. Okay, so two numbers. Product must equal to -42. Product is equal to AC. And the sum must equal to -1. Yes, so what are the two numbers? -6 and +7. Oh, -7 and +6. What did I say? Okay. So what do you do to the 3? You split it up into 1 and 3. Yeah. So this one is 3p minus 7. This one is p plus 2. Yes. So 3p is 7. So p is 7/3. Or p is -2. Are they both solutions? Let's see. If I put 7/3 here, would it be 0? If I put it in the denominator, would this make it the denominator 0? No, so this is the solution. What about negative 2? Negative 2 minus 2, is it 0? No, so this is also a solution. So how many solutions do we have? You have 2, and that is negative 2 and 7 over 3. No, you could just do this. Yeah, I usually just write it because you know this is an equation, right? So I usually write it like this because those are the solutions. Doable? Yeah, easy. Now, same thing with this. This is doable also. Yeah. Okay. So first of all, I want to factor out x squared minus 4. So how do we factor out x squared minus 4? X plus 2 times x minus 2. Now, do I have x plus 2 here? Yes. Do I have x minus 2? No, I have 2 minus x. What do you know about 2 minus x? That's the opposite of x minus 2. So can I rewrite it as the opposite? So what happens if I want to rewrite it instead of x minus 2, instead of 2 minus x, I want x minus 2. Yes, it will change this sign. Yeah. So this is the opposite of x minus 2. So if I want to change it to x minus 2, then I'm going to multiply the top by negative 1, the bottom by negative 1. So if I multiply negative 1 times this, I will have x minus 2. So let's write this again. 12 minus 6x divided by x plus 2, x minus 2 is equal to 3x over x plus 2. Now when I multiply by negative 1, what happens to the top? Yes, so this sign becomes plus 3 minus 2x. And what happens to the bottom? X minus 2. All right. Okay, so what is the LCD? LCD is x plus 2, x minus 2. All right. So multiply everything by x plus 2, x minus 2. X plus 2, x minus 2. X plus 2, x minus 2. All right. Good. Then what? Cancel this one. So you have only 12 minus 6x. How about this? So 3x times x minus 2. Yes. Plus, what about this? 3 minus 2x times x plus 2. Yes. Okay. Good. So 12 minus 6x is equal to, what is this? 3x squared minus 6x plus 3x minus, oh, we have to do FOIL, right? First, what is first? 3x. Outer, what is outer? No, because you changed this one to be positive. So this one we change. When we multiply by negative 1, negative times negative, that is positive. So you still have 3 minus 2x. Yeah, so you're changing this to positive, but you don't change anything here. Yeah. So yeah, you switch the denominator to x minus 2. Yay, nay? Okay, so let's do FOIL here. When we do FOIL, what do we have? 3x, outer, plus 6, inner, minus 2x squared, last, minus 4x. Okay, good. Combine like terms. So I have 3x squared. I'm recording, aren't I? Yes, I am? Okay. So I have 3x squared minus 2x squared, that is x squared. And what about the x? Let's see here. I have negative 10x plus 3x. So negative 7x. And then plus it. Yes? Okay. Now, what am I supposed to do next? This is quadratic, so I have to change it to standard form. How do I change it to standard form? Subtract 12, yes, you need one side to equal to 0 plus 6x. Yes. So 0 is equal to, what is this? X squared minus x minus 6. Is that it? Mm-hmm. Okay. So factor it out. Is it factorable? Yes. What is it? X minus 3? X plus 2. Yes. So what is x equal to? 3, or x is equal to -2. Okay. So now, is 3 a solution? When you substitute here, does it make it 0? No. So this is a solution. How about -2? Is -2 a solution? No, why not? It makes -2 plus 2 is 0. So what is your solution? Only 3. -2 is not a solution. Yes? All of them. You have to check it to all of them. So you have to check it to all of them. So 3, well, this one is not going to be 0. 3 plus 2, 2 minus 3, those are not 0. What about -2? It makes this one 0, right? It makes this one 0. It's not a solution. Because if I ask you, what is 5 divided by 0? Yeah, so any number divided by 0 is undefined. Yeah, so we don't want the denominator to be 0. No, it only switched the order of the, well, it's whatever you want. Do you want to switch the numerator or the denominator? You can. You just have to do one of them. Yeah. It's like if I have -1/2. I could put the -1 on top or on the bottom, but not -1/2, right? Yeah, so it's like that. You have to choose, but in this case, we have to choose the denominator because my LCD is x plus 2 times x minus 2. Oh, okay, yeah. So, yeah, we don't switch the order of the numerator in this case. If we switch the order of the denominator. Yep. Okay, one more, last one. And then I think we should start 6.7. Yeah. Because this is motion, and I think you need to see it because we use it in Math 125. Yeah. So number 6. So it's easy. So I will tell you. Number 6. Now, what about if I have this is proportion. So 7/6 minus a is equal to a plus 1 over a minus 6. All right. There are many ways to do it. Now, what do you notice first? Which one? So, this one? What happens to 6 minus a? What do we say about this? This is the opposite of a minus 6. Okay. So, what do you do if you want to change it to a minus 6? Multiply by -1 over -1. Right? So, on the left, you have -7 divided by a minus 6 is equal to a plus 1 over a minus 6. Okay, then what do we do? Yes? What is your LCD? Yeah. If I want a minus 6, look at this. What is negative 1 times 6 minus a? Mm-hmm. Yes, which is? Yeah. Negative 6 plus a, which is a minus 6. Yes? Yeah. Yeah. If you multiply by negative 1 and you have a subtraction, then you just switch the subtraction. Yeah? Yay, nay? Good? Okay, so what is the LCD now? A minus 6, both sides. Okay, this is a binomial, so I'm going to put parentheses. So this is negative 7 is equal to, the a minus 6 cancel, is equal to a plus 1. So what is a equals to? Negative 8. Is negative 8 a solution? Plug it in. Negative 8 minus 6, is it 0? No, so this is a solution. All right. Yes, no? Doable? Wednesday. But I'm going to collect for the, because you have a test, right? So even though so, I'm going to collect the portfolio. Yeah, on Wednesday during the test. Yeah, okay. So I'm done with 6.6, and I'm actually waiting for questions. Is this doable? Is this easy? Doable? Yeah? Okay. Good. Good. Now, so basically, if you have an equation, what do? We clear the fraction, the denominator, by multiplying with the LCD. Yeah? Okay. Yes, I'm done. So let me save this. Save as. Save as. 6.6, Math 115. 6.6. Save. Yes. Do I want to replace it? Yes, I will. So let's start 6.7 now. So we're done with 6.6, solving rational equations. So we'll start 6.7, which is applications. This is 6.7. Are you ready? So we're going to work now. Problems involving work. All right. Yes. Yeah, the work problems, you need this for Math 125. That's why I need to discuss it. Yes, you will. Yeah.
So we're using the sort of 125 or
this, you will see this in Math 125 also, so you need to get the concept of what it is. Yeah. So 6.7 is applications involving work. I think I have one applications problem on your test. On your test on Wednesday, involving work. But don't worry, this is easy. Okay. Now, what work do you do? What work do you want to do? Like paint this room? Okay. So this is what type of problems, application involving rational equation. I'm sorry. Rational equations. Equations. Okay. And the A part was applications involving work. Applications involving work. Okay. So the type of questions that we will discuss was, okay, something like this. Okay. So suppose it takes me by myself like 9 hours to paint the room. So you say I like painting the room, and then I paint by myself. How long does it take? And then it takes Brian by himself. Brian is very efficient. 5 hours to paint the room. Then the question is, suppose we work together how long does it take? So that's the type of questions that we're talking about. Does that make sense? So suppose by myself, it takes me 9 hours to paint the room. I don't know, I never painted a room. So if you want to have your room in jeopardy of having bad colors, then you can give it to me, right? But Brian, he is very efficient and he's good. He can paint the room in 5 hours. The question is, if we're working together, how long would it take? So what are the possible answers? If by myself, I have 9 hours. If Brian by himself, he will take 5 hours. How about if we're together? No, well, it's not going to be more than Brian himself, right? So how do you think? That's the type of problem we're dealing with. Yeah, so let's write that down. Yeah, okay. So basically what you'll do is a fraction of the hours. Now this is the easy way. So, okay, so it takes, so for example, yes. So what we're going to do is we're going to add this part done by a first person in 1 hour or 1 minute or whatever, plus part done by the second person in 1 hour is equal to part completed by part done by both in 1 hour. Does that make sense? So if you want to do the easy way, then do this method. The books method or Math Excel method is a little bit more complicated. Yeah. All right. So are we sticking with the hour thing, with the painting thing? Okay. Okay. So let's write this. It takes N 9 hours to paint the room, classroom, by herself. Okay, so if I work by myself, it's going to take me 9 hours. And then the result is not guaranteed, right? Okay. And it takes Brian, he's very efficient and good, 5 hours by himself. Okay, to paint. Now the question is, how long does it take when both work together? So these are the type of questions we were asking in this problem. And you want me to teach the easy way or the hard way? Easy way? Okay. Huh? The hard way, you need table. Yeah. So do the easy way, right? Don't you think? Okay, good. So do the easy way. Yeah. Okay, so this is the easy way. So this is the easy way. So I'm going to write this. This is different from book or Math Excel. Different from book or Math Excel. But you'll see it is easy. So you don't have to use the Math Excel way. So remember, before doing 6.7 involving work, what do? Just look at the sample. The notes, class notes, okay? Now, so it's based on part done by first person and part done by second person. It's part done by both. So let's talk about step 1. Yeah. So and how much time do I take? 9 hours. Okay. And my question is, what happens in 1 hour? What part of job is done? So if it takes me 9 hours, in 1 hour, what part is done? What fraction is done? 1/9. is done. Does that make sense? Right? It's 1/9 of the job is done. 1/9 of the room is done. How about Brian himself? Brian takes 5 hours. So what about in 1 hour? 1/5 is done. Okay. How about both? Do we know both? We don't, but we call it X. So this is our variable. Yeah, X hour. So what about in 1 hour? What part is done? 1/X is done. All right. So as long as you know this, then we have the equation. In 1 hour, what part is done by me? 1/9. What part is done by Brian? 1/5. What part is done by both? 1/X. That's your equation. There you go. Doable? So is it pretty simple? So this method is different from book or Math Excel, but this is easier. So I think we will use this, right? So 9 hours, so it's 1/9. 5 hours, so it's 1/5. What about both? 1/whatever X. Okay, since we use X, it's going to be 1/X. Can you solve this? See. Okay. Tell me the LCD. 9 times 5 times X. So the LCD is 45X. Which one? No, there's no 2. Step 2 is the drawing. So you want to take me a picture painting? Okay, so no, we skip step 2, right? Step 2 is table or drawing. If you have a rectangle, those things, or diagram. So we don't. So unless you want to take my picture and Brian's picture while we're painting, then you don't have step 2. Yes. All right. So what do we do now? Easy. Multiply by 45X, 45X, 45X. Good. What are we left with? 5X plus 9X is equal to 45. Yes. So what is this? 14X is equal to 45. So what is X? Divide both sides by 14. So it is 3 hours. 3/14. Right? All right. So how many hours? So step 5, it takes 3/14 hours when both work. When both people work. Yes. You know why I turned it to mixed? Because I want to know how many hours, right? So if you say 3 and 3/4, I got an idea. If I say it's 45/14, then you sort of have to think, oh, how many hours is 45/14? Yeah. So that's why I turned it into mixed number. Yeah. Because I want to know, I want to get an idea how long it takes. So see, it's faster than 5 hours, right? So I'm helping you, Brian. If you're by yourself, it takes you 5 hours. But if I'm helping you, it's 3 3/14 hours. Doable? Okay, so let's do a slightly different one. So, all right. Yes. I'm waiting for questions. Is it pretty clear? Okay. So in the next problem, you don't know how long I take or how long Brian takes, but I said that I take 5 hours longer. So it's going to look like this. So probably it's not me this time. It's probably some other things that happen. Hold on. Yeah. Okay, so let's see. Can I answer any questions? I want some questions. No? Nobody will give me questions? Okay. What about some answers? Does anybody have some answers? No? No questions and no answer? All right. So let's do one more. Yeah. Okay. Let's see. Okay. All right. So this talks about, do you want to talk about helicopter or printer?
Helicopters.
Okay, well, helicopter first, right? Okay, so let's do helicopter. Yeah. So it's talking about helicopter that is used to turn off fire. When you have fire, sometimes they send helicopter, right? Okay. So is the Ericsson air crane, so that's the name, helicopter, can scoop water and douse a certain forest fire 4 times as fast as an S-58T helicopter. So the Ericsson can carry the water, can get the water, and then scoop, and then scoop it, and then turn off the fire 4 times as fast as an S-58T helicopter. So far so good? Okay. So now, working together, the 2 helicopters can douse the fire in 8 hours. How long would it take each helicopter to douse the fire? Working alone. So what about if they work alone? Working alone to douse the fire. All right. This is not hard either. So remember, in 1 hour, that's your equation. Your equation is in 1 hour, right? Okay. Good. So what is step 1 now? So you got 2 helicopters. What's the first one? Ericsson. Good. And the second one? S-58T. So do we know the hours? No, we don't. But what do we know about Ericsson? 4 times as fast. So, okay. So, okay, so 4 times as fast, what does it mean? So if, okay, so let's just a hypothetical. Suppose this can do it in 4 hours. What about Ericsson? So suppose It says it's 4 times as fast, right? Does that make sense? If just say the S58T can do it in 4 hours, what about the Ericsson? How many hours? 1 hour, right? Okay. Just say the S58T takes 8 hours. What about the Ericsson? 2 hours. So it's not multiplied by 4, is it? Okay. Let's just say the Ericsson takes 3 hours. What about the S58T? 12 hours. Just say the Ericsson takes 4 hours. What about the S58T? 16 hours. Now let's just say the Ericsson takes X hours. What about the S58T? How do you get all these numbers? What did you do? You multiply by 4. So this is correct. Yeah? Does that make sense? So you're trying to get these. That's what you're trying to do. So the Ericsson will take X hours, but the S58T will take 4X hours. Does that make sense? Okay, so I'm going to erase this. And then I don't know how long Ericsson takes, but I'm going to call it X hour. What about the S58T? 4 hours? For what? For X hours. Does that make sense? Okay. Yay or nay? I'm waiting for questions.
Yeah.
I still have to keep waiting until the end of time. Oh, you have questions. Good. The one I'm waiting for.
We don't know like the value. We just plug in any number we want.
And then try to get the rule. Yes. Yes. So that's what Sal said was very good. What happens if we don't know? Then we just put in some numbers. So for example, remember what I did? This is 1 hour, this is 4 hours. This is 2 hours, this is 8 hours. So you're just trying to get some rule. So plug in a few numbers or substitute a few numbers and then try to get in some rules, right? Okay. Yes. Good question. Good question. Thank you. So what happens in 1 hour? Oh, together. Do we know together how many hours? 8 hours. Okay. So the question is, what happened in 1 hour? What part is done? 1 hour. What part is done? 1 over X is done by Ericsson. What about by S58T? In 1 hour, what part is done? 1 over 4X is done. What about for together? In 1 hour, what part is done? 1 over 8 is done. No, just 8. It says 8 hours here, right? Together, they can douse the fire in 8 hours. Okay, so can you tell me what the equation is? So no step 2 unless you want to draw a helicopter. Step 3, okay, helicopter and the forest. I mean, I could draw trees, yeah, with fires. What's your equation? 1 over X, that's done by Ericsson, and then 1 over 4X, which is done by the other helicopter, and what's the total? 1 over 8. Yeah. Are you guys okay so far? Are you opening your mind? Yeah. So everything is okay? Do you know why it is 1 over X plus 1 over 4X equals 1 over 8? Because part done by Ericsson helicopter plus part done by the S58T helicopter is equal to part done by both, right? That's why. So part done by Ericsson plus part done by the other helicopter is equal to part done by both. That makes sense, right? Okay. Now, what is the LCD? So you have 4 and you have 8. What is the LCD? 8x. You're right. So let's multiply each term by the LCD. 8x, here is 8x, here is 8x. All right. So the x cancel, and the 8 cancel here. So you have what? 8 plus 2 is equal to x. Oh, x is equal to 10. Oh, this is easy. So which one is x? Is it the Erickson or the Erickson? So do I know the other one? Yes. So Erickson will take how many hours? Will take 10 hours by itself. Uh-oh. And then what happens to the S58P? Will take how many hours? 40 hours. Why is it 40 hours? It's 4 times. So this is your x. Erickson is your x. And this is 4 times x. Yeah? Yeah, it's 40 hours. You know the fire, it will spread, right? That's why we need something like Erickson. Even 10 hours is too long. Yeah, but what can we do? Yeah, okay. You know why they need helicopter? Because sometimes the fire is in the middle of the mountain. I mean, there's no fire truck that can get there, right? What happens if you have a mountain like this? Oh yeah, that's a drawing. Okay, so I should draw a truck. I'm not good at drawing. But anyway, sometimes there is no way. Draw the fire, yes. And then there's no way to get to the place, so you have to use helicopter. No, you can. I can't. I'm not. Like if I ask my daughter, she can, but not me. Yeah. Yes. Doable? So basically, what do you do? So if you have x, then we have 1 over x. If you have 4x, then we have 1 over 4x. If you have 8, we have 1 over 8. So basically, we take this is, yeah. So it's like in 1 hour, what part is done? So it's going to be always 1 over what the number of hours is.
Like the hard part would be finding the average before it.
Yes, yes, yes. So the hard part will be determining what this is. But this is a little bit harder than the other one, right? You say this one is given? Okay. Yes. But this one, you have to figure out x and 4x here, basically. Yeah. Yay? This is 6.7. Yeah. I haven't done it. I haven't made the homework, as a matter of fact. 5, I think 2 of each. So 2 of these, and then there's 2 motion, and then 2 proportion. 8 is okay, yeah. Okay, not much, yes. Okay, I wouldn't put, so today I will put 6.7 homework, okay? Yeah. Now, we're not done with 6.7. Chapter 6 review and 6.7, okay? Now let's do the motion. Did we ever do motion? Yeah, D equals RT. We never? No, we did, right? Yes. So applications involving motion. And then the other one is proportion. So proportion is similar triangle. Motion. All right. So applications involving motion. So can you guys get the sample test and work on them? No, at home. Yeah. So motion is D is equal to R times T. Do we remember what they are? What is D? Distance. We did distance before, right? R is rate. T is time or duration. Okay. And we always have table. Whenever we have motion, we always have tables. Remember? DRT. All right. Okay, so let's talk about trains. Yeah? Okay. Now, so we always need tables. So for example, a freight train, number one, do I call it freight? Freight, right? A freight train is traveling, traveling is one L, by the way. I don't know why I put two. Is traveling, look at this, 14 kilometers per hour slower than Amtrak train. An Amtrak train, sorry. All right. So the freight train travels 330 kilometers in the same time it takes the Amtrak. Amtrak is passenger, right? To travel 400 kilometers. All right. Find their speed. You know this already, so we have a table. I think you do know. So this is the RT, right? Okay. All right, something like this. So this is the distance straight line. And you have two categories. Which one is the freight? Yes. And then the other one is Amtrak. Okay, now we just fill it up. Freight. Find their speed. Their speeds with S. All right, for freight, do I know the distance? Which one is the distance? 330 kilometers. So the distance is in kilometers. And the Amtrak, 400. Do I know the rate? Rate is what? Speed? Okay, so do I know it? This is kilometer per hour, so the T will be in hour. All right. What about the rate?
14.
Is it 14? Should I put 14? So it says what? 14 kilometer per hour slower than. Okay, so how do I say 14 kilometer per hour slower than? So which one is slower? The freight. So how do you write down 14 kilometer per hour slower? P minus 14? R minus 14? Or X minus 14? Okay. Right. Amtrak is X, right? Okay. Because then the freight is X minus 14 because it's 14 kilometer per hour slower. Now, what about the T? Can we solve for T? How do we solve for T here? How do I solve for T? Divide both sides by R, right? So T is D over R. So the T here is D divided by R. I'm going to write this as 330 over X minus 14. 400 divided by X. So I'm going to write here T is actually the distance divided by rate. When you solve for T, divide both sides by R. All right. So this is step 1 and 2. Because you have your Amtrak, the speed is X, The speed of the train is x minus 14. All right, now step 3. What is your equation? The same time. So what am I going to write here? 330 over x minus 14 is equal to 400 divided by x. Yes. Okay. Now, what is the LCD? The LCD is what? X times x minus 14. Yes. Yay or nay? Yay? Okay. So then I have to multiply x times x minus 14, x times x minus 14. So the x minus 14 cancels. So actually you could use proportion here. You could cross multiply, right? Yeah, so you could do that. So 330 times x is equal to 400 times x minus 14. So 330x is 400x minus, what is this? Is 560? No, it's not. Sorry. It's not times 4. What is 400 times 14? 5,600? Yes. And then you're going to subtract both sides by 400x. Okay. So negative 70x is equal to negative 5,600. What is x? 80. Yes. So which one is x? The Amtrak? Okay. So then you have to say which one is. So Amtrak is 80. What's the unit? Kilometer per hour. And what about the freight train? What is it? 66 kilometer per hour. How do you get 66? That's right. At minus 14. Yay? Doable? Yay, nay, yay? Okay, so doable, right? Okay, good. Then we will continue 6.7 tomorrow, yeah? And I'm going to put up the homework. Maybe 8 problems, you said? Yeah? 6 to 8? Okay. Yes. Yes, so let me save this. All right. So, all right. You done with the notes? Let me turn it off and log off. I need to go to my office. Okay, see you guys tomorrow. Yes. Please come tomorrow. Don't be absent. Yeah. And chapter 6 test. Yes. I don't know, but I'm not opening them again.
No, I'm just like
the email?
Yeah. No, like scribbles and quizzes.
Well, you didn't choose quizzes. This is sorry. You choose homework. So let me close the recording first.